Hello students, myself Purva Joshi, Assistant Professor at Delhi Institute of Engineering and Technology. So let's see what we are going to study in today's session. Firstly, we'll see Maclaurin series using differentiation and integration. Then we will solve few examples using it. Okay, then we will solve example using substitution method, and then we'll have the overview of the chapter. So let's begin with the first topic, that is Maclaurin series using differentiation and integration. Now firstly we'll see the method to find Maclaurin series using differentiation and integration method. Okay, so here while solving this we will use the series 1 upon 1 plus x and the series 1 upon 1 minus x. Okay, and we will use this binomial series formula, that is 1 plus x raised to n. These three series we have seen earlier in previous video. Okay, we will use this series to solve the example. I will repeat the series. 1 upon 1 plus x is equal to 1 minus x plus x square minus x cube and so on. And 1 upon 1 minus x is equal to 1 plus x square plus x cube and so on. And the binomial series formula, that is 1 plus x raised to n, is 1 plus nx plus n into n minus 1 x square upon 2 factorial plus so on. So let's move with the example. The first example we are going to study is by using binomial series, find series expansion of function sin inverse x, and using this we have to find the series expansion of cos inverse x. So let's begin with the solution. The for example, so the question is what we have to find series expansion of sin inverse x. So we will take fx as sin inverse x. So firstly find its derivative. So f dash x is what? Derivative of sin inverse x, that is 1 upon under root 1 minus x square. Now we will write this 1 upon under root 1 minus x square as 1 minus x square raised to minus 1 by 2. Now we will compare this with the binomial series. Okay, so binomial series is given by 1 plus x raised to n, that is 1 plus nx plus n into n minus 1 upon 2 factorial x square plus so on. So what we will do, we'll do the comparison of this 1 minus x square raised to minus 1 by 2 with 1 plus x raised to n. So on comparing, you can see this in place of x we have minus x square and in place of n we have minus 1 by 2. So in this formula, everywhere in place of x we will write minus x square and in place of n we will write minus 1 by 2. Okay, so we'll get the f dash x is 1 plus minus 1 by 2 into minus x square plus minus 1 by 2 into minus 1 by 2 minus 1 minus x square whole square upon 2 factorial. Okay, next what we have to do, we have to simplify this. So on simplification you will get f dash x as 1 plus x square upon 2 plus 3x raised to 4 upon 8 plus 5x raised to 6 upon 16 and so on. Now here we have the answer in the form of f dash x. So to convert it to fx, we have to integrate it, right? So on integration, we'll get fx function. So fx function, that is sin inverse x. Okay, so integrate it. Okay, so you will get answer x plus x cube upon 6 plus 3 upon 40x raised to 5 and so on plus c. Okay, now what we have to do, we have to find the value of c. Okay, so to find its value, we'll substitute x is equal to 0 everywhere, right? So we will get in the left hand side, we'll have sin inverse of 0 equals to, on right hand side, in place of x, everywhere you have to write 0. So you will get all the terms 0, 0 plus c, right? So final answer, and sin inverse 0 we know it is 0. So final answer will be c equal to 0. So at last we have to substitute c is equal to 0 in this formula. So we'll get function fx, that is sin inverse x equal to x plus x cube upon 6 plus 3 upon 40 x raised to 5 and so on. Right, so in this sum what we have done, we have taken function fx as sin inverse x. First we have to find its derivative, okay, and then we have to write in the form of power. On comparing with the binomial series, here we have in place of x, here we have minus x square, and in place of n we we have minus 1 by 2. And in the binomial series formula, in place of x we have to substitute minus x square, and in place of n we have to substitute minus 1 by 2. We have to simplify it, and then to get the answer fx we have to integrate it. On integration you will have the constant c. So we have to remove that constant c by putting x is equal to 0. So you will get the value, right? And then we have to substitute that c. Okay, so you will get the final answer, that is sin inverse x series as x plus x cube upon 6 plus 3 upon 40 x raised to 5 and so on. Okay, now next task is to find the series of cos inverse x. Now we know the formula, sin inverse plus cos inverse is equal to pi by 2. So you will get cos inverse x as pi by 2 minus sin inverse x. Okay, so now just substitute the series of sin inverse x. So you will get cos inverse x as pi by 2 minus the series of sin inverse x. So here we have the series of cos inverse x. Okay, now we'll find the Maclaurin series of tan inverse x. Here we have the function fx is equal to tan inverse x. So the next step is what? We have to find its derivative. So f dash x is what? 1 upon 1 plus x square. Now what we will do? We will compare this term with 1 upon 1 plus x. Now we know the series expansion of 1 upon 1 plus x, right? That is 1 minus x plus x square minus x cube and so on. So I'm comparing, you can see in place of x, everywhere we have to write x square. So in this formula, in place of x, we will write x square to obtain the series of 1 upon 1 plus x square. So let's see. So on replacing x by x square, we'll get f dash x, that is 1 upon 1 plus x square, equals to 1 minus x square plus x raised to 4 minus x raised to 6 and so on. Okay, now to find the function fx, we will integrate it. So on integrating, you will get fx equals to x minus integration of 1, that is x, minus integration of x square, that is x cube upon 3, plus x raised to 5 upon 5 minus x raised to 7 upon 7 and so on, plus c. Again same method, right? To find the value of c, what we will do? We will substitute x is equal to 0. Okay, so on putting x is equal to 0, we will get tan inverse 0 equals to what? Everywhere in place of x, just substitute 0. So you will get 0 plus c. Now we know tan inverse 0 is 0. So you will get c is equal to 0. Okay, and substitute just c is equal to 0. So you will get fx is equal to x minus x cube upon 3 plus x raised to 5 upon 5 minus x raised to 7 upon 7 and so on. Right, so in this way, we have solved the Maclaurin series of a function tan inverse x, which is x minus x cube upon 3 plus x raised to 5 upon 5 and so on. Okay, now let's move to the next topic, that is example using substitution method. So the first example here we have is prove that tan inverse of under root 1 plus x square minus 1 upon x is equal to 1 by 2 into x minus x cube upon 3 plus x raised to 5 upon 5 minus so on. Okay, so in this type of example, whenever this type of example are given, we have to suppose something, right? So we will suppose x. So here we will take x is equal to tan theta. Here you have to suppose on the basis of formula you can see in the question, right? So here in place of x, if we will write tan theta, we will get some formula and we can solve further. Okay, so just substitute x is equal to tan theta. So you will get tan inverse into 1 plus tan square theta minus 1 upon tan theta, right? So in place of x, just substitute tan theta. Now 1 plus tan square theta is what? Sec square theta and under root. So we have sec theta minus 1 upon tan theta. Now we will convert everything in the form of sine and cos. So sec theta is what? 1 upon cos theta, and tan theta is what? Sine theta upon cos theta. So simplify and take LCM. So here you will get tan inverse into 1 minus cos theta upon sine theta. Now next we will, what we'll do? We'll write the formula of 1 minus cos theta. So the formula of 1 minus cos theta is what? 2 sine square theta by 2. Also the formula of sine theta, right? That is 2 sine theta by 2 cos theta by 2. Okay, just 2 will get cancelled, 1 sine theta by 2 will get cancelled, and sine theta by 2 upon cos theta by 2 we will get tan theta by 2. Okay, tan inverse and tan will also get cancelled, so finally we will have theta by 2. Now x is equal to tan theta. So theta is what? Tan inverse x. So in place of theta we have to write tan inverse x. Okay, now we have solved the series of tan inverse x, right? So tan inverse x series is what? X minus x cube upon 3 plus x raised to 5 upon 5 and so on, right? 1 by 2 is kept as it is and we have to write down the series of tan inverse x. If this type of question is asked directly, so after this step, that is tan inverse x upon 2, we have to find the series of tan inverse x, okay, as we have solved previously, and then we have to substitute this value to get the final answer. Okay, now let's see one more example, that is prove that tan inverse x minus 3 x into 3 minus 4x square upon under root 1 minus x square into 1 minus 4x square is equal to 3 into x plus x cube upon 6 plus 3x raised to 5 upon 40 and so on. Okay, now again here we have to suppose x. Okay, so we have to think about the formula, right? If we will suppose take x is equal to sine theta and we will substitute in the left hand side, you will get some formula, right? So just substitute it. So on substituting x is equal to sine theta, here we will get tan inverse into sine theta into 3 minus 4 sine square theta upon under root 1 minus sine square theta into 1 minus 4 sine square theta. Just we have substitute in place of x, we have written sine theta. Okay, numerator here is kept as it is, just simplify the denominator. Okay, so 1 minus sine square theta is what? Cos square theta, and we have under root, so it is cos theta. Now just multiply this cos theta in the denominator and simplify it further, so you will get tan inverse 3 sin theta minus 4 sin cube theta upon 4 cos cube theta minus 3 cos theta. We have to just multiply it and simplify. Okay, now we know this formula for sin 3 theta, that is 3 sin theta minus 4 sin cube theta, and the formula of cos 3 theta, that is 4 cos cube theta minus 3 cos theta. Okay, now sin 3 theta upon cos 3 theta, it will become tan 3 theta, and on simplification you will get answer 3 theta. Now x here we have taken as sin theta, so theta is what? Sin inverse x, right? So 3 sin inverse x. Now we know the series of sin inverse x, right, which is x plus x cube upon 6 plus 3x raised to 5 upon 40 and so on. So we have to just write down the series, right? So just write down this series here, so you will get the final answer, that is 3 into x plus x cube upon 6 plus 3x raised to 5 upon 40 plus so on. Okay, so if this question is asked directly, you have to solve up to 3 sin inverse x, right? And then we have to find the series of sin inverse x using this differentiation and integration method, right? And then just substitute it value to get the final answer. So now let's have an overview of what we have studied in this chapter. Firstly, we'll see Taylor series in powers of x minus a. So Taylor series in powers of x minus a is given by f of x is equals to f of a plus x minus a upon 1 factorial into f dash a plus x minus a whole square upon 2 factorial f double dash a and so on. So whenever in the question if function fx is given and it is asked to find Taylor series in powers of x minus a, we will use this formula. Okay, now let's see next. So the next formula is Taylor series in powers of h. So the formula is Taylor series in powers of h is given by f of x plus h is equals to f of x plus h upon 1 factorial f dash x plus h square upon 2 factorial f double dash x and so on. Okay, so whenever the question is given of the type f of x plus h and it is asked to find series in powers of h, so we will use this formula. Next, we'll see Taylor series in powers of x. So the formula for Taylor series in powers of x is f of x plus h is equals to f of h plus x into f dash h plus x square upon 2 factorial f double dash h plus so on. Okay, so whenever the question is given of the type f of x plus h and it is asked to find in powers of x, so we will use this formula. Okay, now let's see the last one, that is Maclaurin series. Okay, so Maclaurin series is what? F of x is equals to f of 0 plus x upon 1 factorial f dash 0 plus so on. Okay, so whenever the function fx is given and it is asked to find in powers of x, we will use this formula. If it is said that we have to find the Maclaurin series, we will use this formula. Also, it can be asked that function fx is given and you have to expand about a is equal to 0. So at that time also we will use this Maclaurin series formula. Okay, so today we had the overview of Taylor series in powers of x minus a, in powers of h, Taylor series in powers of x, and at last Maclaurin series. I hope you have understood all the topics. Thank you for watching.